So we're going to go and march through our Python fundamentals. I hope to finish today. So if not today, then next Wednesday we will finish the lecture on fundamentals. And just before we start, I do remind you that all of the code is actually available in your code subfolder on Canvas. And I have also in lectures updated Lecture2 Python fundamentals to the most complete so far. So it should technically be complete for everything that we're going to cover in this lecture. So again, download your Lecture2 PDF again, and any code you can find either PY or IPYNB, which is a notebook, Jupyter notebook file for this lecture. However, as you know, I do suggest that you kind of follow along and try to type in case you don't manage to type everything in. There's video and there's this recording, or rather the code is there for anything that you don't manage to catch up with. All right, so where have we stopped last time? We went into quite a bit of detail of explaining what do I need for three-dimensional plots. And by three-dimensional, I basically mean function or data that depends on two other data points. So mathematically, I'm having a function f of xy, and I want to plot that surface in three dimensions. Two things we always have to remember. First one is that in order to plot, I have to have data. I have to have a discretization of my space, and I have to have x, y's, and z's of those data points. That's the first thing. Second thing is this is 3D plot. Okay? In 3D, I'm going to plot onto the screen or print on the paper. However you turn it around, it is a projection. And that projection takes time to process. Okay? So in a projection, you have an object that you're viewing. You have a viewer that is sitting in a certain position. And that viewer is looking at certain direction and seeing that object. And question is, what does that viewer see? That's what we want to see on the screen. When I change my position for a different view, I want to see a different thing. Okay. So you can see how this changes or could change interactively. Here we actually just going to do a static projection. But if you ever play games or watch movies that actually have artificial world in there, okay, that's something that somebody has to program. You, as a player in the game, are moving around, you are turning around and looking in different directions, and when you do, you want to see a different scene. And that scene has been exactly computed and presented to you on the screen. So it is actually a non-trivial problem, and I'm grateful, even though I personally don't play video games, I'm grateful to that community because they're driving scientific visualization to places where scientific visualization has never been, okay? And they're actually also making the hardware that goes along with it, video cards, right? Much better and more advanced, so all of us can benefit with better visualization on our computers, regardless of whether you play games or not. So it is unknown. Why is this display again like this? But yeah. I thought I swapped this display, but apparently not. So just a quick recap. So if I want to plot a surface like this, first thing I need is sort of discretization on my xy domain below, and I need x and y coordinates for every point here that is intersection of two lines. Okay? So as a recap, my x's here on this line will be -2, -1, 0, 1, 2. But my y's will be just -2, 5 of them. And then the same thing here, but my y will change to -1. And so forth, I keep going. So I need to create two matrices, and x and y in those matrices in the correct positions are corresponding to x and y coordinate of that plane below. And then I need to compute z corresponding z, and after that I can plot. So let's actually do that, okay? And I have functions that can do that. So I'm going to switch to my notebooks, and I'm going to This is my Jupyter notebook, so please open what you started last time, or if not, just start a new one. So in order to create my discretization of the space, I'm going to use my NumPy lim space that I already know really well. So if I create 5 points between -2 and 2, that should be precisely what I need for my X discretization, one array. And I can quickly print it so we can see what it is about. And then I'm going to do Y, the same thing. Okay? And if I print X and Y's, those are 1D arrays. And I have a function called meshgrid, okay, that will help me create these matrices. So I have to kind of replicate all of the X's. I have to replicate Y times for each X. And all Y's, I have to replicate X times for each X. So essentially, meshgrid helps me do that. So this is a built-in command. It takes my 1D arrays X and Y as input, and it gives me matrices as output, and I'm going to print them to see what they are. Okay? So this was my X. This was my Y. And these are my X and Y matrices. So if you recall, my Y had, in the first row, it had constant -2s. In the second row, -1s, 0, 1s, and 2s. Okay? And my X had constants, but in columns. So first columns is -2s and -1s, 0s, 1s, and 2s. Okay? Just to look at a little bit at meshgrid. So meshgrid outputs, it has 2 outputs. I have to know that about meshgrid. And if I want to catch them and save them, okay, I can just put them in order. What do I want them to be called? X, Y. I don't need any parentheses. If I actually put parentheses, it's going to be okay too. So whatever you want to do. But X, Y equals to output of the matrix. Output of the built-in meshgrid command. So now I have X and Y's. My next job is actually now to compute my Z values. And let's say that I want to plot function that is Z of xy, 2 minus x squared minus y squared. If I just wanted to compute that for every of these points where I have x and y, okay? Technically, I would need to go and loop through every point that I have and create that output. But here, I know that my NP arrays, I can work with the entire matrix, right? So how do you remember how to do power of something to squared? How would I do that? 2 asterisks. So this is my, if I just want to print x squared, here we go. It's right there. So if I want to just compute 2 minus x squared minus y squared, this is pretty much what I would do, because I already created my x and y's pairs, and each position in these matrices is corresponding. Okay? So that's what I'm actually now trying to plot. This is my function. So again, in NumPy, this is why we want to use NumPy. I can operate with the entire array, and I can do all the mathematical operations you could ever think of all at once. So I'm just going to, instead of printing it, I'm actually going to assign that to a z.
I'm only getting one line of output.
Did you use uppercase x and y as output by meshgrid? So if you use lowercase x and y, you're going to get only one 1D array. But uppercase x and y are 2D arrays. So I'm going to comment this printouts, and I'm actually move this up in my cell. So this is my step one. I have the data. Okay? I have x's, y's, and z's. All of them are matrices. And the sizes correspond to each other. Now I want to plot. Okay? So there are two things I need to tell. So first we're going to import. So this is just creating the data. Now I'm going to import my standard friend for 2D plots and figures. And that is who? What is the module for 2D plots? Lib, specifically PyPlot, and we're going to call it PLT. We're just going to stick to one name for things. So this is my standard figures that have two axes, and I'm plotting something against each other. Now, in order to embed my 3D plots into that, I need more help, and we're going to say, okay, from MPL toolkits mplot3d. So mplot3d is my 3D plotting module. We're just going to import axes because this is really where the problem lies, is how do I represent three-dimensional axes inside a 2D figure. I'm going to just import it, so whatever I actually have here, when I use it, I'm not going to give it any last name, such as PLT. I'm just going to call it directly. So these are the tools we need. So now I have to dance a little. I can't just go plt.plot the way I could in the regular plot. I have to dance a little to tell Python, hey, embed this 3D axis projection into a figure. So for that, I actually have to create a figure first. I do that by plt figure. And I'm going to remember that object, and I'm going to call it fig. Why? Because I want to modify it later. So whenever I actually want to modify something, I kind of have to store the output. Next thing, I need to tell it, hey, make this, by the way, I'm letting you know that my axis will be a 3D projection. Okay? And I'm going to remember axis as AX. You can give it another name if you'd like. And I'm going to that figure object, I'm going to add a subplot. I'm going to have only one, so I'm just going to tell it it's one. There's total number of 1, 1, 1. So it's one and only object, really. But that object is a 3D projection. And now I'm finally actually ready to plot. So I created the figure. Yes?
The one, is that a sentence of 1 by 1 by 1?
Yeah. It's just that this is now mplot3d, so it has ever so slightly modified. This is the problem of different modules. All of them could have their own little rules how they call it. Do something. And these modules, basically, which ones are the best, they let, it's open source software. So the time shows which one is the best. So they're never really strictly monitored the way a company would make sure that everything is kind of done the same way. Does that make sense? So that's why you have kind of slightly different rules how you plot things in 3D versus 2D. Okay? And now really, we're just going to these axes, we're going to plot surface. And all we need to do is say, at the very minimum, just x, y, z. I need to plot surface is my main function here. And I often have to execute things twice. And now I get this surface. So at the very minimum, you need to open the figure, tell it it's going to be a 3D projection because that takes special computation of how it's going to look like. And then this axis, you're going to add surface to those axes that you just created, which is why I needed to remember where the axes are. Now, just like we had subplots before, you could have multiple subplots here. Okay. But we're going to have one, so we're not going to concern ourselves with that. Cool. Now, let's say that I want to do a little more colorful plot. There's all the possible color schemes you could think about. I'm going to let you, from this plot, which is in your slides, pick the one you like. Gray, bone, pink, spring, summer, autumn, winter, cool, hot, copper, you name it. The most common one, magenta, sure. Plasma, has plasma. And this is a selection, all right? If you go to this page, feel free to click on it or just to search for it, color maps in Matplotlib. You will get this like list that is forever. The most common one that you actually see in literature is not on these plots because I'm going to exemplify it here, but you could say color map equals to jet. Jet is that rainbow scheme. Whoops. Oh, CMap, never mind. You would put here, so this is color map, jet. Oops. So there was a magenta request here. Apparently it doesn't like this plot. Look at that. So wow. No. I'm never gonna, let's try gray. There we go, gray. So magenta has issues. Let's try summer. Here's summer. So magenta, possibly I need to import something to get it. Here's summer. Huh? Now, if I actually wanted a sort of like, it's also nice to put the color bar. What do these colors mean, right? Then I actually have to record sort of the address of this object surface. And then I say, well, to my figure, please add color map that actually relates to this surface. Otherwise, it's not going to know color map of what. And then, oh, color bar. There we go, color bar. There we go. Now, the only thing that I don't like in this whole business is that it's a pretty crude plot, right? Because I wanted a small example of x and y's so I can show them to you nicely, how they're created, right? So now I can go and change that. I can just say 50 points, make this nice and fine, okay? And I'm gonna execute everything by doing run. Oh, there we go. Now this is smoother. Yes?
Color bar doesn't work.
Color bar doesn't work. Fig dot color bar.
Fig dot color bar.
Of surface, and you remember what surface is on the previous line? It needs an object the color bar refers to.
Yeah, it looks. Oh, no, I didn't do circle.
Yeah, you have to do that. Otherwise, it doesn't know which object. Yes. So, Ningu, if you can walk around and see what the shoes are.
There we go.
At the top, you see how she made that third line.
So I had to return surface here the object address. So there was in the third row, third row. Are there still issues in the third row with plotting? Right in front, the ladies.
On the y-axis right there,
The very minimum y-axis.
right next to the color bar.
I didn't label axis or anything.
Well, I'm saying the one that goes straight up and down. Yours starts at 1 at the top, mine starts at 2.
What it starts from, Python decides unless you specifically tell it. And we're going to get to that in the next example. All right, everybody got some plot? If not, please calling you for help. So again, the key thing is having the data, okay? Then creating the figure and telling Python, hey, this is going to be a 3D projection because it's a projection onto the screen. And then you plot that surface. You can specify color map or not. I'm never going to really test you on color map, okay? But for your presentation, this might be relevant, okay? If you're actually creating a plot that matters, that you're going to show to somebody that matters, then you want nice choice of colors and all that stuff, okay? But for us, what matters is that you need to have data, X, Y, and Z. You need to know how to create it, and that's this business here, okay? So once you create the data, you need to tell Python, hey, make this a projection, 3D projection, and plot surface. All right, let's play with this a little more. We could technically just plot wireframe, okay? So I'm gonna comment this part. And I'm just gonna say, hey, plot wireframe. Also of X, Y, Z. So this is a different function. My plot will look like a wireframe, as the function would tell you. And then I have something like this. I'm going to let you decide which one you like better for different things. Different ones might be. So now if I actually wanted to modify this a little in terms of limits and stuff, I can modify 3D axis by setting X limits to be whatever it is that I want them to be. Or I want them tight, so -2 to 2. I can set Y limits, also tight. I can do Z limits if I wanted to. I can do X label. I can do Y label. I can, of course, do Z label. This is getting boring a little. And when I do, I will see X, Y, Z. Now, if I actually wanted to change the angle, so this is, Python has chosen for me, how am I looking at this 3D plot? It has chosen a viewpoint, elevation, and everything. If I actually want to play with that, right, you can do X view init. And the way it's done is providing there is 2 values, elevation and azimuth in degrees. Elevation is elevation in Z, okay? And azimuth is azimuth in XY plane. How am I rotating XY axis with respect to the viewer? So if I do 0, 30, whoops, if you actually type it correctly, then this is like I'm standing, basically, my elevation in Z is 0. I'm standing on the Z is equal to 0 plane. And this XY is kind of rotated at 30 degrees in front of me. Think about it. If you put your elevation again in degrees at 90, you're going to see a top-down projection of this, which is very boring in this case. And you can see that this Z is kind of condensed into a point. So this is your XY projection. And I think it's better to actually plot surface here. Let's see some color. Okay? So I changed it to plot surface CMAP just to show you some colors, because the wireframe is, when projected, it's just as if there is no plot. So again, you can play with this. I'm going to go back to 0.30 because that way I actually see proper surface. And I can see, again, my 0, it's my elevation in Z is 0. So again, for 3D projections are not necessarily trivial. But good news is that there are ready-to-use tools. Good? All right, this should be fun, and you're going to get some 3D fun with your homework. If you actually wanted to save this figure, all you would need to do for any figure that you create is say fig.savefig and then the name of a file you want to save it to. So if you want to add this at the bottom of your code, you can, and then there will be a file that will show up. And that's then a figure that you can take wherever. That's just if you need to use it somewhere else. Email it to someone and so forth. There's plenty of examples online. I provided links for some of these just in case you would like to play with them. There are contours that I'm not going to go over here, but you can. It's a very similar game to play with the contours. So these are three-dimensional contours. You all know contour maps. If you ever went hiking, you got a contour map. Easy hiking is when you walk along a contour because you're never changing elevation in Z. So basically it shows you lines where your function Z that you're plotting is constant value, and it gives you which value you have. And in the lecture 2.5, the Jupyter notebook that I uploaded, there are examples for these contours that you can play with. Okay? So it could be basically a 3D contour or a contour in 2D. Okay. And these are the two that we exemplified. Cool. This is just the fun times from my personal research. I do quite a bit of fractures. And this is aperture map. Aperture is fracture opening of tight gas sandstone fracture. You can see actually quartz crystals growing and propping the fracture open. That's where my aperture is 0, because I actually have this bridge and there's no opening. And in between is what the space that is left. So I could actually plot that contour. So this is your color map chip or rainbow kind of coloring of these apertures. So this particular one was open between 0, where it was closed, to up to millimeter or so. So very small fractures in tight gas sandstone. So again, these are the possible visualizations. This is a so-called contours or contour. I don't think this movie will work. Oh, it will. You can actually, when you create a sequence of these projections that are moving in certain direction, you can very easily put them together in a movie. Movie is really just passing images really quickly in front of your eyes, much quicker than your eyes can adapt. And that's creating this, it's an image of things continuously moving, even though there is actually just like, there is probably about 20 frames that have passed by here. Okay? So you can do those things, again, at your own time. We're not going to do, maybe we will do creation of a movie later. But it's not something I will test you on. This is just so you know that you can do effective visualization. So these are individual lines plot with the contour. And these are actually so-called filled-in contours. So I can take a contour of something and just say, fill it in with black color, fill it in with red color, and so forth for effective visualization. In this particular case, this is gas moving into water is white, and these are grains in black. Okay, so this is drainage and imbibition. And we can do imbibition as well. So this is gas withdrawing and water coming back in. Okay? All right. So this basically closes our chapter on plots, 2D and 3D. And we're going to now move with a little more boring stuff, but necessary nevertheless. How to save read information profile and save it. Now that is a very broad discussion, and we're just going to do basically 2 or 3 very fundamental examples so you get the feel of how it works. If you wanted to share data with a friend of yours, you these days send an email, and that email has text. So text files we regularly share. However, as an engineer, more likely than not, the data that matters is some sort of a number. Now that numbers, if it's a lot of numbers, you might share an Excel sheet, for instance, right? But if you want to process that in something other than Excel, you need to know how to read it in. So we're going to do very basic reading and writing of text files that might have a combination of text and numbers. And I'm going to show you one efficient way how to save just a NumPy array and then load it from Python. All right, let's get moving. So first thing, we're going to figure out how to interact on the screen using input. We already did that once, but now we're going to figure out how to print it a little better on the screen. So printing information, your program has computed something and you want to simply tell the user, hey, this is what it is. So you need to format your output better. This is Lecture 2.6 input output. Sorry, something is. I'm going to create a new notebook. So you can either just go along with me. I have posted Lecture 2.6 input output on for you to use. So we have already done input command, I believe. So I'm just going to say, okay, record this input string. I'm going to call it string in. And the way input works is you could just say input, but then in that case, the computer is just waiting for you to type something in without telling you, hey, type something in. So I'm going to simply say, hey, please input a string. String is a small text array. And when I do that, computer will tell me, please input a string. So whatever you put in here is just a message that you want to give to the user. Doesn't mean anything to the computer itself. So I'm going to say hello. Okay. If I now wanted to check whether this was correctly stored, I can print this string. And this is what we've done already. So any variable I have, I could just print. So cool, it got recorded correctly. Now, if I really actually wanted to do something else and communicate with my user a little better, do a little customer service here, then I say the string you entered was, so this is a string in itself. I'm just gonna separate, so I can basically pile up things I want to print and just separate them by comma. So this first thing is a string, right? And then this string is in another string. So I can just separate it by comma and just dump it, and it's going to print it just fine. Yeah? Actually, it's very flexible, so you could actually do a plus as well. The only difference is that it's not in between a comma and a plus. It's leaving a space and not leaving a space. Okay. So I can basically, to a print command, I can put whatever I want, and I just separate things by commas that I want to print. Cool. Now let's be a little interactive here. So I'm going to say, hey, name, input, what is your name? And I'm going to say, hey, nice to meet you. So I'm going to type in my name. Nice to meet you, Masha. So this gives an appearance of the computer having some intelligence here. Whereas it's just programmed to do so. There's these online shrinks that can go on and on and on. It asks you to ask a question, and then it like continues, like it grabs something from the conversation and keeps asking questions. Yes?
Is it better if you're using apostrophes or?
No. That's really nice of Python. And it's really nice if you know any other programming language, then you're used to one or the other. Python doesn't care. So the question was, does it matter which type of thing I use here? No, it doesn't. It's gonna annoyingly put in the second one the moment you type in one of them. Okay. I can continue this conversation. I can say, how old are you? And then I can also be smarty pants. You are already It can be more interactive. I can just add my name to it too. See what I'm doing here? Creating a full conversation. And I just keep adding pluses or commas. The only difference will be a little spaces, and we're going to fix up spaces as we go. What is your name? Masha. How old are you? 41. Thanks for asking. You are already 41 years old, Masha. And the problem is that plus doesn't do spaces, so I'm going to add some space here. So we can go on like this forever. This is just playing with strings. The problem is we often want numbers, and this input is stored as a string. So you can say actually print type of age. And even though age is numerical, it's stored in as a string. It's stored in as text. So if I wanted to compute with it, I cannot. But I can convert. So let's try convert. I can say, hey, can ask for how old is your friend? Ningyu, how old are you? Oh, youngster. Okay. 29. So it has those both ages as strings. If I wanted to actually sum up how both of us, how old are we together, then I would do something like together you are, and I'm gonna convert my age, or let's actually first compute that. So age together is integer of age plus integer of age of my friend.
That's not interactive.
Whoops. Age together. Did I mistype something? Oh. That apparently does want commas. Oh. So Ningyu, together you and I are 70 years old.
Mine's not interacting.
It's not interactive?
No.
Here it doesn't like a plus because you would add integer to string.
No, I'm
So-
talking
so
like
you have-
before the start of the conversation.
That's a conversation non-starter.
It was interacting before.
Yeah, mine doing the same thing. Only working before.
It somehow also started like in star.
Yeah. I already knew that.
Created into some star. Okay, so
I copied everything, including whether she did a space. I noticed that you don't have a space. And you'll know if it's like working or not.
okay. Save. This is all in lecture 2.6, already uploaded or everything, and with more comments. And if you can play with this a little. For some reason, this changed to a star. Why is it running? Alright. Alright. Now I actually want to print some information to the file. And the process of printing to a file, so just before we actually start printing to a file, I'm gonna quickly go to file formats. So file format is typically recognized by extension. And there are certain standard formats that we're going to use and that you already interact with on a daily basis. So images are often .png, .gif, .jpeg, .pif. What was it?
There's a same problem here.
Joy. Simple problem. .txt is text. Docx is proprietary file format for word processing. .py is a Python. That's really just a text file, and it's interpreted by Python. So you can give any text file to Python as long as you have that Python interpreted. So you can also define your own format, but whenever you do that, whoever you give that file to has to know how to read it. Okay? Now in text files, it's actually simple because you look at the file and you realize how you need to read it by just reading it. If the file is binary, then you don't see the text and you don't know what's the mumbo jumbo underneath and how to read it, then you really need instructions on how to do that. Luckily, there are certain standard formats that we can do. So what we need to do when we are writing even simple text to a file, we need to open the file, which finds the memory space for it. And we need to tell it what the file of it will be, human name for it, that you will be able to find on your computer. And what is the mode of opening it? Do you want to read, write, or append, add information to it? And then you write, and this write command works pretty much like print. Okay, you can print into it whatever you'd like. It's just that write knows that it's actually doing that into a file, not on the screen. And then you need to close it. So let's do a very simple example of how to do that. Okay. So first thing that I'm going to do, I'm going to open the file. And the command for that is open. And I'm going to say simple text file.txt. And I'm literally going to go one of these print commands. And I'm going to borrow it. And I'm saying, hey, my file is now object. That's how it's a file object. And if I say my file.write, then it knows how to write into that file. And basically, whatever I wanted printed in there, I'm going to actually save into the file. And again, pick your favorite print command from the above and print that into a file. And they say, my file, close. So open, write something, close. Oops, and then I have an error. Oh, I didn't tell it how to open the file for writing. I mentioned it while talking. And then I have more. Here I need to use plus so that it creates one string to write into the file. Apparently it did something. So again, write works similarly to print, but you do need to use plus in order to put together one string to write into the file. You can actually keep writing here. I'm gonna do this hello just because. And another thing that I might want to do is print. So I need to also tell it how to print next, go to next line. Don't do everything in one line. And that there is a special way to refer to that character. It's /n. That means it's a command to go to the next line. Okay. And now in your files, you can find this simple text file. And you can see it in your browser. So in your files, this file should show up. You can click on it and see it. Yes? All right.